Good morning, good afternoon, hello, good evening, hi. What is happening to you? How are you? Look at this. Uh, yeah, I'm sorry. Yeah, like okay, I see what's happening here. So there is some confusion about my schedule, and that's because I don't have one. But I know this would be a lot easier for my channel if I did. It's just, first of all, I'm not very good at this, and then second of all, it's like 10 o'clock my time, which is when I used to start my day. And then for these live streams, I try to start more, like I try to start sometime around 8 um, in the morning, which is way earlier than I'm happy being awake. But that's fine. And then also in theory, I travel, right? In theory, I get on planes and go talk to people. Hey, I might even meet some of you in person this year or next or whatever, or maybe I have in the past. I don't know. So I've got to keep I can't like promise to be there every day. Uh, but I try to do it every day. I try to do it every day around 8 o'clock my time, sometime around 8. And if it doesn't happen, usually I'll remember to post on YouTube or on Twitter or something. But yeah, follow me on Twitter. It's not the worst mistake you can make, probably. And yeah, and sometimes like this one, so here's the thing. What a real professional would do, and I've watched other real professionals, so I know what could be done. I'm just not there yet. What a real professional would do is they'd schedule it like well ahead of time. They'd be like, oh, I'm going to talk about this next month on Tuesday or something, and my streams are more stochastic than that, right? We're just kind of making it up as we go along, right? I happen to know a lot of this stuff that we're talking about, and so I'm not completely lost. But it's not like I do show prep. I don't have time to do show prep. I've got to do ASCII art jokes and stuff. My life is, I wouldn't call it hard, but it's busy. Lots of other stuff, okay? And so these live streams they give me life. I love these. These are so much fun because I get to learn new stuff and hang out with cool people. But it's not like I can do 5 extra hours off stream for every 2 hour on stream. So and plus I've with you all, it's just been great. I can make mistakes, and we can arrive at a solution one way or another, and that's good, right? So anyway, my point is my stream schedule is not particularly well publicized. I do try and publish it like half an hour before I go live when I realize I have something. Today, actually, I was delayed even in announcing the stream because, and again, this is a real thing. Somebody has to like design the thumbnail, the card, the YouTube card, the image, right? I had to like put that together. So I couldn't publish. I couldn't go live until I had the card. It was just a simple chicken and egg thing. Again, one of these days I'll make it professional. Let's see. Hello, Kunal. Hi, buddy. Good to see you. Hello. By the way, happy Friday to all of you. I hope you're all having a wonderful day wherever you are in the world. I can't believe it's Friday. So anyway, yeah, sorry about that. I don't have a fixed schedule, but again, I try and stream every day, 8 o'clock to 10 o'clock ish. I'll start anytime in between there on my time, California time, PST. And I do that because I recognize that most of the population, save for those of us in the Americas, will already be able to sit down and watch a YouTube channel by the time I amble to my desk at 8 in the morning with my cup of coffee. It's just us in the Americas. We've got our 4 time zones, whatever, here in the Americas, and so for those of us here, it's a little early for us to be watching YouTube, but that's okay. They can watch the recap. Let's see what else we got. Hi from Ukraine. Hi, buddy. Hi, I'm good to see you. Thanks for joining me. Thanks for joining the show today. That's so cool. I was so glad to see the ICC issued that arrest warrant this morning. It was just like obvious, but anyway, hi. I'm really sorry about the nightmare surrounding you for the last year plus. I'm glad you're here. I'm glad you're safe for the moment. yeah, I published. So anyway, I published the notification like 30 minutes, and then so if you're on YouTube, like and subscribe. See, that's what the professionals would tell you to do. Go to my YouTube, youtube.com / @coffee software. Like and subscribe, and you know, that way you can get notified. There's a bell icon, I think, right? That's the thing. Let's see, what else? What else? There's a Twitter. Yeah, I stream these on Twitter just because, you know, why not? But I really prefer if people watched on the YouTubes. Twitter. Hi, hello, Abid. Nice to see you. Good morning, good afternoon, good evening. Hello, Nabil. Hi, hello. A real professional would be promoting his new book right now. And then, oh, hey, yeah, I did an ebook. Let me show you that. That's fine. Thank you. That's a good reminder. Spring Boot 3. Okay, so let me share my screen here. So here it is. This is everything you never wanted to know about Spring Boot 3 AOT. It's free. It's got the low price of $0, and it's I wrote it. You know, it's not great. It's fine. It'll be okay. It's 50 pages. It's really just a very long pamphlet or whatever. But so you just go there, fill out the form because they want to, they want to get your information. This is a VMware Press thing, right? A VMware whatever book, and I wrote it right after Spring Boot 3 came out, but then it takes a minute for us to turn around a book and get it out there for y'all. So here it is. You can download it for free. It's everything you never wanted to know about Spring Boot 3 AOT. And actually, I did this. I did the Bitly thing, right? So if you go to Bitly Spring Boot 3 -GraalVM ebook. Wait, I'll just copy and paste that. No. Okay, we're gonna just try this too. Okay, there. If I take that, I can paste this in the chat. There you go. That's a book. It's fun. Books are good. Let's not burn books. These are going to be useful someday. So there's this. Get it while you can. I mean, I don't think it'll ever stop being available, but get it. What else do we got here happening today, my friends? What else do we have? Hey, Mahir, that's so cool. GitHub internship. That's congratulations. Oh, that's awesome. That's super cool. Smart people doing smart things. I hope you'll still have time to join us once you've made it big. You'll remember, the little people. But that's amazing. Congratulations. That's so cool. GitHub is GitHub is one of those companies where I wish I could pay them more. I've tried really hard to pay them more. I just don't it's what I've even talked about this on Twitter. There's two tools where I just feel like I'm not paying enough. One is IntelliJ, right, which is just fabulous, and it's been great I've been using it probably close to 2 decades, maybe more, right? It's 2002, so yeah, more than 2 decades, right? And it's been great the entire time. It's been stellar the entire time, and even when it was not open source, because there's an open source edition of it now, IntelliJ IDEA Community, which is fine. If you're a Spring Boot developer, you don't need anything more than IntelliJ IDEA Community Edition, right? And the reason is because it doesn't support application servers and all that stuff. But if you're just doing regular Spring Boot, public static void main, self-contained jars, you're fine. It'll support that. It works just fine with that, right? You should get the professional one because it has the auto completion for properties and that kind of stuff. But and it's a fabulous tool. But the IDEA Community Edition is amazing. You can do the job with Spring Boot just fine. You'll just have to use the config props endpoint to see all the property names, right, in Actuator. And so IntelliJ and GitHub, two tools for which I can't seem to pay enough. I have 600 repositories across 50 different organizations or something like that, right? I don't have a larger presence anywhere than I do on GitHub. I have do you can have followers on GitHub? I don't even know how that's a thing. I think I follow a few people, but there's 8.4 thousand people that follow me on GitHub, and I just feel terrible for them because it's, my code is abysmal. And in fact, I used to, because I have so many different repositories and so much stuff there, I eventually had to over last winter, I think a few months ago, I moved everything to another repository called Josh Long-Attic, another organization. And here you can see there's 532 repositories. These are the ones that were just created as one-offs or whatever, things I started for a project or a conference or a demo or somebody had a question or whatever. I just moved everything here. And a lot of stuff that wasn't just that. There's a lot of other stuff that's here that's more interesting. But basically, it's all just stuff that I'm no longer keeping in my mental RAM. So I love GitHub. You are working for one of my all-time favorite companies. They've emerged from the sort of awkward, stumbling missteps of being a nascent startup and turned into a company I can really admire. So good for you. Congratulations. Let's see here. Oh yeah, so there you go. That's the other thing is IntelliJ, they just give it away. What? So even before it was open source, that's what I was trying to say. Even before it was open source, you could go to a Java user group. Java user groups are your friend. I know it's super hard now because there's COVID, right? There's this pandemic, and so it's hard to resume in-person meetings and whatever. But if there is an in-person meeting near you and you're willing to if you feel like you can do so safely, wear a mask, do all the things you need to do to make sure you're safe. But if you can go, these meetups are, I'm not sure about now. I mean, I've been to a few since the pandemic, right? I've spoken at half dozen or whatever since the pandemic. But especially before, it was just such a great place to meet and learn and grow, right? And so one of the things I loved about that is that IntelliJ or JetBrains, they gave away licenses for IntelliJ. You could just answer a question, right? And they'd be like, "Oh, okay, free license for you." Well, thank you. That's great. I appreciate it. I got a new follower. It seems like I lose one every other day and gain one, and that's okay as long as most people are not dissatisfied. But yeah, I love IntelliJ. They just give it away. They used to give it away. Maybe they still do. I don't know. But it seemed like I couldn't if I was tripping and falling down when I stumbled and hit IntelliJ licenses just laying on the street. They're just everywhere, right? And then if you're a student, they give it to you. If you work in open source, open source at all, just contribute to open source. They'll give you a license for free, right? I work in open source. I have a license there, right? But I also pay for the whole pack. I pay for the whole, they give you every IDE that they make. If you want to work in Python and Go and JavaScript and CSS and all, they have all these different amazing Ruby, all these different IDEs that you can use, .NET. They have all of them under one pack. And I think I don't even know what it is a month, but it's trivial, right? It's cheap. So I pay for that personal, my own personal license there. What is it, 50? It's got to be it's even less than Adobe, and Adobe was $50 for everything, right? Just a phenomenal thing. So IntelliJ and GitHub, I have dozens of, like I said, dozens of organizations for books and all that, and they're all using GitHub Actions, and I've got some private repositories, and I've even paid for some of those because I wanted to have private GitHub Actions and all that kind of stuff and collaborators. But they by default is free. Most things on GitHub are free, and it's just an incredible value. I don't know how they make money, but I'm sure grateful that they do. So, okay, friends, I think let's get into it. Today, I wanted to talk about Spring integration, right? Spring integration is it's amazing. Hello from Brazil. Hello. Yes. Hi. Good to see you, by the way. I'm sorry I didn't see your message. Yeah, Brazil. So again, it's not cheap to buy IntelliJ, but there are a lot of ways to get it for free, right? And open source is one of the easiest, right? They support other groups. Let's see, register. How do I get a free IntelliJ license for students? Yeah, I don't know. Businesses, okay, individual developers. It's $17 a month basically, which is still a lot of money. But there was a time when did any of you use Borland JBuilder. Anybody here remember that? Right. JBuilder was insane, right? JBuilder was one of those things where I could only use it at work. It was so expensive that there was no way for me to take take it home. It was thousands and thousands of dollars. It was like the Java alternative to Visual Studio Code, right? Not Visual Studio Code, Visual Studio, right? And Visual Studio is also famous for being very expensive. Although compared to what the alternative was, it's very cheap, right? Back when it first came out, Visual Studio was a very cheap way for developers to start writing C++ and C and all that stuff. It's amazing how the dynamics of this stuff has changed. But it used to be that if you wanted to use a tool to write software, it wasn't free. Far from it. It would cost thousands of dollars back in the 90s. And now, you have Eclipse, you have Visual Studio Code, you have great options everywhere. It's just blows my mind. And IntelliJ is, in my mind, it's the best tool on the market at the moment. And you can use it for free. For Spring Boot, you can just use the IntelliJ Community Edition. It's fine, like I said. And if you get a chance where you can buy them and buy the professional one and pay them for that, do that. It's amazing. Okay. I'm kind of interested to see how today's stream goes, because today is the first stream where I got myself a little toy, right? And I have one of those. I have a Mac, right? A MacBook Pro with the M1 chip and all that. And it was getting to, I have a microphone, I have a monitor, I have a mouse and a keyboard. And I changed my keyboard. You've heard me talk about that, right? I got a new keyboard, but this keyboard is not wireless. It's got a cable. It's smaller, so it takes up less space on my desk, and my desk feels like it breathes better, but it does have a cable. And so now it got to the point where, okay, every time I sit down, I have to plug in 4 different cables. So it discourages you from taking your laptop and just going to the living room if every time you have to plug in 4 different cables. And that keyboard that's the 4th cable. And I was like, I don't want to do that, So I got this thing, very expensive, but it was worth it. This is what I saved this is like a late birthday gift to myself. This thing, I don't know if you're in the market for this, but this thing is amazing. It's just one plug now, right? M2 Air, those things are amazing. M2s are, I want to get the M2 as well, but anyway, I looked at it. I have the M2, I have the M1 Max, and I looked at the M2 Max. I'm like, it looks good, but not that much better. Apple did themselves no favors by making such an amazing device, But anyway, I got this. This thing is amazing. This is a box into which you can plug in your keyboard, mice. You can do 2 4K monitors or 1 8K monitor. No, Mike, I bought this myself. Yeah. I bought this myself, unfortunately, and my company would not let me expense this. But I bought it, and my desk is so much cleaner. I can take my laptop, unplug 1 cable, and then go anywhere, and then plug it all back in, and it's got power, microphone, monitor, keyboard, mouse, camera, my Sony A7S III, studio camera sitting above my monitor, which I'm not using right now. I'm using the webcam, but no, M2 is great. No, M2 is great, man. It's amazing. It's just I already had the M1 Max, right? And so I didn't want to buy the M2 Max because, like, if you had Intel and then you bought the M1 Max, the difference is like this, right? There's so much difference between the Intel and the M1 Max. It's night and day, like so much faster. But if you buy M2 Max versus M1 Max, it's like that. It's obviously better, but it's not like so much better that I need to spend another $5,000. I just spent $5,000 on this laptop in 2021. I might use it another few more months. It's fine. Suddenly I had some nice motivation to fill them. Yes, that's a good point. Exactly. That's why I don't want to lose my job, because otherwise I can't afford this nice little toy. So anyway, I don't know if anybody's in the market if you have this problem, but I was running out of ports and cables and patience, so I finally got this thing. That's another thing. We'll see if so far nothing is shorted out. I don't see any sparks, so should be fine. Okay, everybody, let's get into it. So today we're going to talk about integration and messaging, and we're going to talk about Spring integration. And I fully expect that is Express JavaScript backend fast or Java Spring Boot backend is fast? Both? Yeah, they're fine. Spring is, that's where I would go, but they're both very fast, very scalable. And if you're using reactive programming and GraalVM, I don't know what else you need. Okay, so let's do this. So we're going to build a new application today. We're going to use Spring integration. And again, Spring integration, I've talked about this before. Spring integration is the project to which I first started contributing bugs, right? When I first joined the Spring team, it was because I was a contributor to Spring integration. And the guy who created it was Mark Fisher. And I don't know how you define beat express, right? I don't know how you measure for yourself. Try out your use case. I would be interested to know. Like Java is among the fastest languages out there, and reactive programming or Project Loom, it makes it among the most scalable. So, I don't know. Try it out. It's like if you had asked me that question in 2010. I would have said no, because of course not, right? JavaScript at that point hadn't gone through a lot of evolutions. But raw performance isn't interesting, right? It's not going to help you. What you should care about is, can I get my application in such a shape that it serves my customers in production quickly? And can I do it with relatively, economic sense? So if Spring Boot is a little bit slower, but it's not that much slower, and you can scale up by adding another instance in your cluster, then do it. It's fine, especially since we have a huge ecosystem and all that stuff. Okay, so Spring integration. So Spring integration is an integration technology. It's one of these things where it's sort of central to everything. It is. If we've talked about this before, I think, but let's just Gregor Hope, Bobby Wolf, enterprise integration patterns. Here you go. This book is everything. This book changed my life, right? Because it defines the lingua franca of messaging and integration. It provides a framework, not a software framework, a conceptual framework by which to think about the integrations of software systems and data. And it provides the language of that integration, right? And so, if you understand these concepts and the patterns described therein, then you're ready to use Spring integration. This book is amazing. It's an amazing book written by amazing people, and it came at a time when the world was kind of changing, right? I don't know if you've ever used a service bus or an integration broker, right? I've had the dubious pleasure of using lots of them, right? Web Methods and Axway Integrator and MQ series and what's the other one? Not TIBCO. TIBCO, but no. Anyway, all that to say, lots of different integration technologies out there. BizTalk, I've never used that one, but that's another one. That one is Microsoft ecosystem. I'm sure there's people who use it with Java. That's the whole point of it. It's an integration technology. But all these different technologies are they're from the old way, from the old day, from a long time ago, right? The idea was you had one of these, you paid millions of dollars for them, and they sat in the middle of your business, and they acted as a hub through which everything routed. And so all business logic changes for all services, no matter where they were, had to go through this hub, this giant monolithic broker, right? This messaging broker, messaging system broker. And the more integrations, the more you paid, right? That was kind of how that worked, right? That's it's just a very sort of old way of thinking, and it was all the things that people don't like, right? Which is you get these like big ball of spaghetti services where everything routes through it. You can't untangle your code from this giant thing that now requires super careful change management, and that was hard to upgrade and scale out. And so that was the old way. And then we started moving from enterprise application integration servers to enterprise service buses, right? And I think that's basically largely the same thing. It's a different name for the same thing. And service buses were, they were, I think a lot of them tended to focus on XML and to focus on open standards. But basically they were the same thing, right? And so these service buses, you had things like, by this point you had open source things. You had things like Mule, right, which is a service bus. You had Service Mix, Apache Service Mix. You had a few things that just came out of that space that were kind of service buses. But at some point, I think it became very clear that it was very easy to think about integration in terms of the applications that they worked with or that they affected. And so then we have some of these open source libraries, and there's some in other languages, I'm sure, but in the Java space there is Spring Integration, and then another great one that came out was called Apache Camel, right? And so these are libraries. These are not servers; they're libraries. You can add them to your code base, right? They hang off of your application, and then the difference is if you're using Spring Integration, with Spring, it extends the Spring idioms for messaging. And so I think I was, the other thing I was kind of debating when I thought about this series was, should we start lower? Should we start at the level of like Kafka and RabbitMQ and Apache Pulsar and whatever, and JMS? And I think I might very well come back around and do individual treatments on each of those things. But I want to talk about it at this level because I think it makes more sense to start at Spring Integration. And if you have to dip down, then you can, right? But I wouldn't recommend trying to build interesting things at lower levels. I think Spring Integration is the right level to start. There are higher level abstractions still that you could pursue that are perhaps even better for what you're trying to do. But Spring Integration is where I'd start conceptually, right? In terms of abstractions. And so Spring Integration extends the concepts, the idioms, the patterns that people have come to expect in a Spring framework project, so things like templates and all that, while adding new ones, right? Designed to support the lingua franca, to support the patterns espoused by this book, right? So I love Spring Integration. I think it's just an amazing thing. And in a sense, if you read this book, then you already know Spring Integration because the patterns are named one for one after the chapters and the concepts introduced in the book. So I guess that's just important to keep in mind, is this book is the blueprint for that framework. We built it one for one on this. In fact, speaking of Eclipse, if you're using the Spring Tool Suite, there is support. There's drag and drool design times, or at least there used to be. I'm not sure about now, but there used to be, there probably still is, design time support from designing WYSIWYG flows, right? What you see is what you get flows with Spring Integration. The icons that we use in that tool come from this book, right? Like my friend John Davies, he's another integration guru out there. He's doing big and beautiful things with finance these days, but for a long time he made his bones in the wide and wonderful world of integration and messaging, and he's the first person I ever heard call them this, which was, he says these icons are Gregorgrams, right? Gregor's the author of this book, right? So you might see these icons. You might see these icons used to represent common patterns. And like, for example, the concept of a channel looks like a pipe, for example. You've probably seen diagrams drawn this way. And that's because they all owe a lot to this book from 2004, right? It's an amazing book. Okay, so with that background, let's just talk about integration. And I guess today we'll just do basics. We just have to like focus. And we should probably do something a little bit more interesting than just the file. But even there, I feel like I just need something. Actually, we'll just do file for now while we're getting started, and we'll start ramping up. because I want to introduce the patterns, and then we can talk about the integrations, right? That's my thinking here. I don't know how long this stream will go. I don't know if we will have like dedicated discussions of, I mean, not this particular stream, this series. I wonder if we might have just discussions of like Kafka and Pulsar and FTP and SFTP and all that stuff, or what, or if we just keep going and create new series after that. But for now, Spring integration, that's all you need, right? So hitting generate. Oh, you know what this means? This means I have to remember my Java code. I just got used to Kotlin. So open that, and while I am remembering, github.com, let's code Spring integration, repositories. Okay, that took a minute. Let's code Spring integration. Okay, we're gonna make this public. Add a README. Gradle. Package licensed, of course. Okay. Okay. Here we go. Downloads, CD integration, git b. Actually, you know what? Move this integration. Sorry, I'll go back. Move integration to desktop. Let's code. We're going to call this basics. Okay. Commit -a basics git push. Pretty. All right. Good. So we did it. We got that there. Okay. So now, let's see. SFTP. Yeah. I mean, well, I don't want to set up certificates live on stream and all that, but maybe. But we could do FTP for sure, and that's conceptually the same. You can just set up the certificates yourself. Let's see. Okay. And also, if we did FTP or SFTP, I could use my one of my all-time favorite toys, which is the Apache FTP server, right? Which was originally built as a demo for Apache Mina, which in turn is the library that Trustin Lee worked on at Apache. Basically, there was a time when Trustin Lee, who created Netty, Netty, he was working on. He had a go at building something like Netty at Apache, and eventually, you know, the work kind of stopped there. But they built some amazing demos just to prove what was possible, and they built an FTP server. And that FTP server is actually quite good. You know, you can build, like, I wouldn't want to build a modern architecture on anything based on FTP, but if you want something to prove it out or whatever, that would certainly work. And you can plug in custom users and all that stuff with Java APIs. It's just a library after all. Okay, so integration. Keyboard. Building Spring Boot native images without internet access. Is that worth pursuing at all? Oh, you're talking about building containers. What happens if you do just Gradle, native compile or Maven native :compile? Does that work without internet? I don't know. That's an interesting question, my friend. Competing consumers. Yes, I mean, that's a good idea. We could do that. We'd need a broker though. But yeah, there's lots of patterns. We could definitely, yes, that's a great idea. We'll get there. I have no doubt. We'll get to something like that because, again, it's the whole point of messaging. I wanted to talk about Spring integration first, and so let's just start from the basics. You saw yesterday we looked at Spring integration in the last live stream on Kotlin. Whoa! By the way, awkwardness at the keyboard. That's not because of the new power. That's just because I don't know how to type on this keyboard. Okay. So first things first. These days, there are a lot of different ways to create integration flows. Technically, you could just create components, right? I could actually create a method and annotate it with service activator, right? Like that. Public void handle incoming message and whatever. But instead of doing that, I like to use the integration flow because it makes it more clear what we're trying to do. We're trying to define a flow that integration flow dot from, and that flow sources, it originates and terminates a message pipeline. Okay, and so you can originate the messaging pipeline from what's called an inbound adapter or gateway, right? Which is something that takes a real event in the real world and turns it into a Spring Framework message object with a payload and headers. Or you could originate the flow from a channel. And so, hello, hi, welcome. In Spring Framework, we have this concept of a message. This used to live, this message type that you use when you're using WebSockets and so on. This used to live in Spring Integration. It came from Spring Integration, right? And then we moved it to Spring Framework because it's so very generic and very useful. So you have, there you go, see Mark Fisher, that's the original code from Spring Integration. It's been in Spring Framework now since Spring Framework 4.0, which is 2014, right? Maybe even 13. And so eventually we rebased on that. So now there's no more message object in Spring Integration. It comes from Spring Framework, but it wasn't always like that, right? This is a relatively new module. Spring Integration precedes this module by like a decade almost. 2014, 2007. So not a decade, 7 years, right? But a long time, you know what I'm saying? There's a long time before which we had this type. So message comes from that package. And there's also this concept of a message channel that comes from this package. A message channel is a pipe. So when you build integration flows, there's an implicit connection between components in this flow, right? The message moves through channels to components, through another channel to another component, and so on until it eventually terminates. So again, you originate the message from something, it flows through channels to components, and then it goes on as long as you need it to, and then eventually it terminates. That's a flow, right? Basically, and you could do this. You can write code very, very verbosely if you like. You can say, I've got a message channel. A to B. Okay, let's just keep it very simple here. So return message channels dot direct dot get. So I've got a message channel. I'm going to say, okay. So first of all, I want to have a message source. Okay, message source string. My job is just to return a new message. I'm just going to create random nonsense messages. Okay, with payload hello world at instant.now. Okay, there's that. And built. Okay, so I'm going to read it from there. The question, of course, is how often am I going to read it from that message source? And I can use this. I can say polar dot pm dot fixed rate 1000, right? So we're going to read it from there, and then we're going to send it out on a explicit channel, right? So we can say, okay, we're going to send it out on this channel, A to B, right? Well, I've created a flow that just originates a message and sends it out on a channel. Well, what happens then? Well, then some other thing you can have another flow, right, that listens for that. So I can say, okay, integration flow, flow 1, whatever. And say return integration flow dot from A to B. And then I can do other things with it. I can handle it. I can, let's say I want to just log it out or something. I don't know, right? New string get. Okay, so in Spring Integration, if you have a component that returns null, that also terminates the pipeline. That's the end of the line for the messaging flow. Okay, so the payload is good. Okay, got this. Let's see what that does. There you go. You can see every second, it's sourcing a new message from here, and it's sending that message out on a channel. And then another component listens for messages coming in from that channel and then writes out some data. Okay, so this is very explicit. I'm doing everything in terms of channels. Now, of course, in this example, I don't need a channel. You know, a lot of times you don't need a channel, but it's nice to know that behind the scenes, conceptually, every component has another channel that connects it to another thing. But if you don't want to, if you're not trying to like reuse that business logic, then you can centralize all that. You can put it all in one big flow like that, right? You can just source the data from a pipeline, send it to the handler, do something with it, and you can keep going. Like, for example, I might take the data from this message source that I created, which is a little silly, and then I might transform it, and I'll do it using a new generic transformer, okay, of type string to another type of string, but this time uppercased. Okay. Source dot to uppercase, that kind of thing right there. Okay, so there you go. We have a pipeline where we're transforming the data, but we need to let's make this a little bit more interesting. Okay, so let's say that we want to publish a new message. Right, and this is, again, you don't normally publish your own messages. That would be silly. Normally, you're listening for messages in some other part of the world. We have an inbound adapter, and we'll get to those in a second. But as an example, just so we can kind of see how these pipelines work, let's suppose that we're going to create our own messages. Okay, so private even string text, and we're going to say, okay, math.random greater than 0.5. Then we want to say this. Good. Or whatever. I mean, what's another thing we can do that is whatever. I don't know, something like that. Okay. So now we've got a different text being generated randomly here, and I might want to filter those. Okay. So I can filter text. I can say, okay, use a new the types that it accepts are generic selectors or an actual string expression language. So I can say, okay, string.class is the type I'm expecting. And I'll say, okay, do I accept this message? Source.contains, right? Let's copy all that. Okay, there's that. So, yeah, we've got this different flow where we're detecting if it's got a Spanish word in there, and we're filtering it, right? So now we've got this pipeline where we're taking data. We want the filter to go before the transform because it's going to be lowercase. If the filter matches, then the message gets sent on to the transform, and then it gets sent on to this to be logged out. Okay. Pretty simple. But now you can see we're only getting this text over here. If I don't have that, I get both, right? So why does this matter? Why am I showing you all this? Well, Spring integration makes it very easy to think about messaging in a functional style, right? Notice that I've got this very strong isolation. Each of these components is written in terms of a message that comes in with a payload and some headers, and it returns a message that goes out that has some headers. So in this case, these filters are actually just returning Booleans, for example, and these transformers are returning the changed payload. But behind the scenes, every time we act on these payloads, it's being turned into a message, a Spring framework message object that has a payload. Can you replace Apache Camel with Spring integration? Well, conceptually, they serve the same use cases, but there are some places where Apache Camel might have an adapter that you want to use that maybe Spring Integration doesn't. And so you can also use, there's actually a Spring, you can use Apache Camel within Spring Integration, right? And so, they conceptually they serve the same role, but Spring Integration it's more integrated into the Spring ecosystem as a whole. So they're both good choices. Now, so I've got these components: filters, transformations, handlers. These are pretty straightforward. The important thing is we're building a functional pipeline. Every single component has a payload in and it sends a response out. Very, very, very functional. And that's nice because it means you can write code. I can have classes with business logic that are written in terms of these interfaces, right? And by the way, all of them can be written in terms of, like, I'm using these methods here. But basically, if I wanted to, I could do most of the work with just handle, right? I could just do, instead of doing a filter, I could return a message or null. Instead of doing transform, I could just return another message, right? So like if I wanted to change this, so this code still works, but the lowest level like version of that is handle. So, and the contract is pretty straightforward. If I have a new generic handler that takes in a string, I get a pointer to the string payload because I've got it there defined. I've got the message headers. I can say, okay, well, for the filter, I'll say, okay, payload dot contains Ola, right? So if it works, then my job is to return the payload. Otherwise, I return null, and that'll act like the filter, right? That'll replace the filter. It'll do the same thing as the filter was doing before. And then what about the transformation? Well, new handler, new generic handler, string. I got the payload, to uppercase. So as long as I'm returning a value, so again, I can use handle for basically, all the other things that we just looked at, filter, transform. These are just kind of conveniences. Behind the scenes, everything is written in terms of like message handlers, okay? And they're just wrapped in terms of this DSL that we can understand. So let's run this and see if that gives us basically the same behavior. There you go. It's giving us only the capitalized OLAs, right? So you can use handle a lot of times, but it's more expressive to think about it in terms of these DSLs. And also you get some conveniences, like for example, filter returns a Boolean, so you don't have to worry about returning null. It just either it returns true or false, and the framework makes it work for you. Okay, so Spring Integration is all about these functional pipelines, and you can reuse these pipelines by feeding in data from channels, as we saw earlier. So I can create this is a message source. I told you I'm creating a message source that just returns data randomly all the time. But you can originate messages from a message channel, like we saw earlier. So, greetings. Okay, I'm going to call this greetings. Okay, I can use that channel. I can say, okay, let's just originate it from there. Greetings. Okay, from message channel name, message channel. What's the issue with this though? Oh, okay. There you go. So I'm returning, I'm sourcing the messages in the pipeline from this message channel. Okay. Now anybody with a pointer to that, anybody who's got a reference to that channel can then put data into the channel for this components downstream to process. So like if I go here, create a bean.
Here's what I found.
What? See? So messages or greetings dot send, message channel, message builder dot with payload text, right? For var I equals 0, I is less than 10, I plus plus. Pretty straightforward. Okay, so I'm just going to send 10 messages when the application starts up by injecting the channel. There you go. There's our 10 messages. 1, 2, 3. Well, those are the 10 messages that we sent that were then filtered. And so we are only seeing the output of the 10 messages. Okay. So the point is these channels are your input. That's how you invoke another pipeline, is you send messages into the channel that it draws from. And this is how you can create reusable, composable flows by the building blocks of integration. are these little pipelines, right? And now you know how to parameterize them. You can send data into these channels, and they can be fed into these flows. So channels are a great way to send data and to work with data within the Spring framework. But like I said, a lot of times, what is the app you use to give shortcuts tips? Shortcuts. Oh, you mean the plugin? Yeah. I think you're talking about IntelliJ, right? So let's see. Key. Yes, we can use Kafka as a source input. Absolutely, and we'll definitely look at that. Maybe even today. I'm not sure about today, but you can use Kafka. You can use Pulsar. You can use FTP. You can use file servers. You can use anything, and that's the whole point. Is that Spring integration comes with batteries included. So key tip. I don't know, what is it? Bring some my plugins here. Installed. What do I have installed? I've got Key Promoter. Is that it? I think that's probably it. It helps you learn essential shortcuts while you're working. Oh no, that's probably different. Okay. Is it Presentation Assistant? No, where is it? There's a Key Promoter X. Am I doing, is this it? Oh, this one. Yeah, this is the one. This one shows the name and the Windows or Mac shortcut of any action you invoke. So I don't even notice those anymore. Is that happening? I'm sure it is. Let's see. Not now. So yeah, if I do, oh yeah, look at that. So I'm doing Command-Shift-A, and you can see it down here. It's yeah, good. Okay, so anyway, let's talk about inbound and outbound adapters. Okay, so I talked about I said you can source data from anything, right? In the simplest case, I've used a message source, right? I created a message source earlier, right? And that message source, like imagine I had something that, whatever, static class my message source implements message source, right, of string. Not that one, no. Get message. No, different message source. This is for localization. Message source, Spring framework. Message source. There you go. Implement that. So this is the basic contract of a message source, right? And your job is to return a new message. When do you return a new message? That's a separate concern, okay? Because think about it. There are two different types of sources of data. There are things that you have to ask questions, and there are things that will tell you things, right? And so think about like FTP servers, right? FTP servers don't tell you when there's a new file. You have to log in, list all the files in the directory, and then if there's a new file, then you can say, oh, I found a new one, I'll publish it. So how often do you log in? Well, that's a poll. You have to poll, like P-O-L-L, right? So P-O-L-L is a poller. You have to set up a poller to poll the source. But some things like IMAP idle, IMAP for email, IMAP idle, right? Some things will tell you when something has changed, right? And Kafka, same thing. Well, you can ask it to let you know when something has changed. It'll keep a socket open, and it'll monitor the source of the data, and it'll publish a notification whenever something has changed. So you can message sources are kind of like suppliers. Exactly, great way to think about it, right? Yeah, but they're suppliers that have to be invoked. So how often do you invoke them, right? And the question of that is left to, let's make this a Spring Bean, okay? Just add component. And we'll go back to our earlier definition, message builder.with payload text. Right, did I get rid of my method? I'm gonna make this static. Okay, dot build. So I've got a message source here. I'm going to inject that. I'll inject that into my bean definition. So my message source and my message source. Okay, I'm going to read from that message source. But the question then becomes how often. And since message sources need to be invoked, you need to provide a polar definition. So that's what this whole thing over here is: the source polling channel inbound and adapter spec, and you have to specify polar, and then you specify the metadata, the polar metadata, right, about the particular polar. And there's, let's see, factory, and you have a couple of options here. You can get things on a trigger, right? You can create your own custom trigger, and we'll talk about those in a second. You can use a cron expression. You can say I wanted like every Wednesday at 2 o'clock, right? You can use fixed rate and fixed delay. So fixed rate and fixed delay always confuse me. Fixed rate, let's see, polars at fixed rate. Fixed rate. I think rate means like once every second, no matter what, even if the thing that was running before hasn't finished. Whereas delay might mean what? Let's see. Of course, there's documentation. Let's Google it, friends. This is easy. Difference between fixed rate and fixed delay. Spring integration. Okay. Here we go. Fixed delay specifically controls the next execution time when the last execution finishes. Right. Fixed rate makes Spring run on a periodic interval, even if the last invocation is still running. That's what I thought. Okay, so I think that's what I just said. I got it. I wasn't sure, but I think that was what it was, and that was right. So basically, fixed rate is every second, no matter what. Fixed delay is it runs a second after the last thing finished, right? Which is slightly different. So if the last thing took 5 hours, then it's not going to run every second during that 5 hours. It'll run a second after that 5 hours is finished, is I guess my understanding of it. But the point is we want to like consume data in a consistent way. So let's just say I'm going to do 1 time unit of seconds. Okay, right? So I'm configuring, and by the way, I just do P, usually P, there you are. It's a little bit simpler that way. Okay. So message source, P to P, polar, polar factory. This DSL, by the way, was created by Artem Bilan. He's the current lead of Spring integration. He was a contributor to the project. He's Ukrainian. He's a contributor to the project from outside. He wasn't part of the Spring team for a long time, and he was just such a helpful, amazing person. And one of the things he did when he joined was he created this Java DSL, and it's just like I've been using Spring Innovation since it was very, very brand new, and this is my favorite way to do it now. I don't even remember how to do it the old way now. I just use this all the time. It's so good. This integration flow DSL, amazing. One of my all-time favorite like refactorings of a core API. You can use the old ways, it's fine. It still works, right? But this is something else. I love it. Okay, so you can say I want to read from that message source every second. And the reason that's important is because you're separating the concern of where the data is coming from the concern of how often it should be retrieved. Some things you don't need a polar, so you don't specify it, right? If you don't need one, don't provide it. Like if the thing will produce its own data, then you don't need to worry about it. And so this you wouldn't want to do a message source. Or actually, if you specify a message source and you don't specify one, I think it's just 1 second by default, right? Let's see, 5 seconds. Let's see what that gives us. But some things can also just publish data whenever they publish data. Oh, what happened here? Dispatcher has no subscribers. Oh, message source. Filter, transform, handle. I don't think that's true. Oh, this. Right, I'm still sending, I'm publishing messages into the channel, which no longer is connected to a flow. Okay, so now it's running every 5 seconds, taking its sweet time. There it is again. So there's the first time, second time, and so on. And this will just keep going forever, right? So that polar is very important. The polar separates, and you need to have that, but that means that if you use an FTP inbound adapter, or if you use a file inbound adapter, or if you use an email inbound adapter, then you don't have to there's not a custom duration or interval that you have to specify for each of them. It's a generic concern extracted by the framework, right? Extracted out into the framework. Okay. How about parameterized message source, like get data from the last ID processed from last execution? You mean how do you create a message flow based on a particular thing, like data? Is that the idea? I think maybe you're asking, is it possible to create your own integration flow? And yes, you can launch them. They don't have to be beans. I did this before. This is not actually that hard. Let me see, developer advocacy and repositories and Twitter gateway source main Java. Okay, so what this does is it creates an integration flow. Is that it? No, that's not it. I'm looking for, what am I looking for? Blog promotion, maybe. Let me see if that is it. Yeah, okay, so I'm building an integration flow manually here, right? I'm building an object of type integration flow. Where is this used? Build promotion. Okay. So build is it pipelines and launch integration? Integration flow. Context. Here you go. You integrate. You inject a integration flow context. Okay, and context registration, and then you register and start. Okay, so let's try that. So here, I'll just make this a private static. Build flow, and what maybe I want to do something for a custom predicate, right? So I can say string filter text, okay, whatever. Just some example of parameterizing it. And so the filter text we'll put here, okay, and the time as well will be in seconds or whatever. You could have your own time unit, I guess. Okay, so there's my custom flow, and now bean application runner, right? Return application runner. And I'm going to inject the integration flow context, context.registration, var flow, Ola flow equals build flow, and we're going to inject that message source, my message source. Okay, so my message source. And then we'll do this one every 1 second, and this one will be Ola. Okay. And this one will be hello flow, right? And hello. And this will be every 2 seconds. Okay. So I'm going to do set.of Ola flow, hello flow, but for each flow, And we say context.registration flow.register.start. Now you can register them, but maybe you don't start them until later. Maybe you need some other external thing to happen. In this case, I'm just going to start them manually. Okay. So there we are. I've got 2 olas and 1 hello. Okay. So let's try this. Now you should see, you see integration. Let's see. Integration flow dash #1. Oh, I think I know what's happening. Does this return? Wait. Ola flow is the second one. So what about the first one? You see 0. It might be related to threading, right? It might be that I have to set up the task executor. So executor. Okay, let's try that. Wait, doesn't it say hello? Oh, it's capital H. That's why that one isn't showing up. So I don't think it was related to this. It's just not the right text. Hello, there you go. So you can see this one is from one thread, one pipeline. This is the other one, and they're both just kind of doing their own thing at their own time, right? So maybe I can print out the payload for filter text is filter text. There you go. So I'm doing different pipelines for different parameters. Does that kind of answer your question? That's a good question. Thank you for reminding me about that. Like, that is a very good trick. That's a new thing, by the way. That didn't exist 5 years ago. Maybe it's 6 years ago. It's fairly new. Integration flow context. Where is that thing? Yes, you can get chunks of data from a DB and start different flows. Now, obviously, in this case, this is an unlimited flow. I wouldn't want to do that because you would eventually run out of threads. But like integration flow context. This is from Spring Framework, Spring Integration 5.0. So that's in the last 5 years. So when did this come out? I think this came out in Spring Boot 2.x timeline, right? So that would have been 2017 or later. But yes, okay. So you can absolutely create parameterized integration flows, and that's what I'm doing in this thing. For example, this thing actually starts up different pipelines for different Twitter threads, right? For different blogs, and it monitors the RSS feeds for each one of them. So I've got like half a dozen blogs that I need to monitor. So I can start up a flow to monitor each one of them, right? Exactly. And I do that. You could do it for like when somebody makes a HTTP request, you could kick off an integration flow. Yeah, 100%. That's a very natural use case there. So maybe you have some sort of processing you want to do, okay? Now, in this case, we're kind of treating Spring integration as a thing that you can invoke. And a lot of what I've talked about here has been, I'm using Spring integration through a channel to send data into the pipeline. I am using the integration flow context. By the way, let's go ahead and save this off because that's a good checkpoint. Git status, git commits integration flow and integration. Okay. Good. Okay, so we've got this. Let's just simplify a bit here. Go back to the way it was before. Okay, integration flow. So okay, we've got our custom. We don't have the parameters anymore, do we? So this is one. Good. So what we've got here is we've got our pipeline that we're using to process data. We're treating Spring integration like a thing that we can invoke, like a function almost, that has this complex business logic. And the interface to all of that could be as simple as just a channel, right? You can create your own integration flow as well, but even that, you could have a channel that listens for a message, and whenever it gets a message, it kicks off an integration flow, right? Based on what's in the message. So the interface to Spring integration as a messaging system, all this complex business logic, all this event-driven business logic that lives behind the channel. The channel is the input to your system, right? And we'll talk about inbound adapters in a second, but the point is you've got this mechanism, this channel, that's your contract. Message in, message out, message in, message out. And so all of the communication between components, I showed you, you could use generic handler for all of them. Message in, message out. I can use channel to start off a new integration flow. Message in, message out, right? It's like a pipes and filters architecture, right? It's like this. When you do desktop, echo, hello, to, source, whatever. So I can do cat source. Okay, grep, actually, while true, do echo hello random to source. Okay, I'm gonna hit go and then Control C. So cat source has all this text, right? I've got a file here on the command line. It's got 86,000 lines of text in there already, right? And I can do things with that. I can cat it. That's my inbound adapter. I can pipe the data from that. And so the data I'm going to get in that pipe is standard in. And then I can say, okay, grep 2020. Okay, what does that give us? That gives us a lot of messages still. I want to then count all that data. I can use WC, right, to see that. And I can then write out that data to another file. So source, target, right? Now I've got this pipeline, that little pipeline I just showed you. The inbound adapter is the cat. I'm piping it to a grep and then piping that to WC, and then the outbound adapter is this redirection operator. Okay, that's a pipes and filters pipeline. And the reason that's so interesting is standard in is my currency. It doesn't matter what these programs are written in. It doesn't matter what languages they are using. It doesn't matter what they're doing behind the scenes. They at the end of the day, they can all be used with just standard in and standard out, right? You can compose them any way that you want, right? It creates a very nice, clean, reusable system. That's why Unix is so amazing, right? Is I can reuse these components on the operating system and just reuse the individual things any way I want. It doesn't matter if source was written 20 years before grep or whatever, something like that, right? It doesn't matter if I'm using a tool that I wrote today and I'm also using these 5 other tools that were written in the 70s, right? I can reuse them because they all speak standard in, standard out. In Spring integration, everything speaks channels and messages, and you can reuse components because they can be strung together. They don't know about what came before and they don't care about what comes after. And this is why it's so valuable to write code like this. Is you're encouraged, you're forced to write in terms of clean, well understood, well documented, well described functional pipelines, right? That's the power of Spring integration. Okay, any questions on any of this? I mean, so far we haven't even covered any inbound adapters. So we're going to do that, and then we'll call it a day for the day. But we'll talk about inbound adapters. Obviously, so far we've just been talking about channels, and the other thing is you can treat Spring integration like a system that you invoke. But if you don't want to give people a channel, if you want your API to hide the fact that you're using Spring integration, you can do that. And the way you do that is by using something called a messaging gateway. Yeah, Spring Cloud Function is very similar. Spring Cloud Function, in fact, behind the scenes, underneath, is using Spring integration. Yeah, absolutely, right? Very, very similar. Okay, so let's try this. Interface, greetings, client, okay? Messaging gateway, okay? And what do I want to say? I want to say string greet string text. Okay. So here I'm going to say what do I use here? Messaging gateway and start template. Okay, messaging gateway, messaging endpoint. Oh, you have to use a integration component scan. I don't know if that's set up automatically or not. Integration component scan. Okay, so we're setting up that, and then we're creating an interface. Now the question is, what do I put on this method? Let me see. Spring integration messaging gateway. Default request channel. So a default request channel should be, and the request channel is, let's say that this code is now getting its data from greetings. Okay, so we're going to say from greetings. Okay, so this is no longer necessary, right? So default request channel is greetings. And actually for now, that'll be enough. Actually, we'll just call this void. Okay. And so the pipeline will be data goes into the greetings channel. We check and see if the message has Ola. If it does, we uppercase it, and then we print it out. Okay. I've got this interface now. So now in another code base, you have the impression that Spring Integration and Spring Batch are very close. They are two sides of the same coin, right? Batch is for sequential data access, large amounts of data, lots of data, right? I have 1 million rows in a file, and I need to process all of them. Okay, I use Spring Batch. But who notices the file in the first place? What code will discover the file is there and then tell Spring Batch to do the job? Well, that's Spring Integration. Spring Integration is all about events. Batch is all about tasks, right? So the fact of the new file, that's a Spring Integration message. The processing of the file once the file has been discovered, that's Spring Batch, right? That's a good way to think about it. And they are often used together. I might have a workflow where I put data in an FTP server, and then Spring Integration notices the data, and then it publishes an event, and then that's used to kick off a batch job to process the data. Okay. Okay, so now imagine in another component, another part of my code, somewhere else, application, greetings, client runner. Actually, just do that. Class runner implements application runner. Private final greetings client. Implement that. Here, this greetings client dot greet. Hola. Okay, so I'm going to use the greetings client. The payload is for filter text is Ola. Okay, so well, whatever. Result. Okay, so you can see the program started up and it ran result Ola, right? And so if I do this again, for var I equals 0, I is less than 100, I plus plus, text, where's my text variable here? This. Okay, so now I've got this random text, and it's going to give us either Ola or hello. And you can see we got, some of them are Ola, but not all of them. That's not 100 records, right? From here, oh, maybe that is. I don't know. What is that? So there you go. Yeah, how many lines is that? I don't know, but let's make it simpler to parse. There you are. There. So 1, 2, 3, 4, 5, 6. So 6 of them were hola. The other 4 were hello. Okay. So we're using the pipeline from this interface. We have no idea. When you inject this bean, this type of greetings client, you don't know that you're actually invoking a whole messaging pipeline behind the scenes, right? And all that you have to care about is that I've got a bean that does what I think it's going to do. And then, in fact, I can even, let's just return that, okay? So now I'm going to change this to become string greetings, right? Let's see if that works. Let's see what that does for us. Okay. Interesting. Is it blocked? What's the, oh, do I have to like specify a return channel? Uppercase greetings, greetings results, greetings requests. Okay, so we go here, greetings requests, channel, greetings results. Okay, so data comes in from the request, we do some work, we send it out on the results. Now we're going to take this results and put it on the interface here. So default reply channel is that. And then requests. There you go. So any data? I guess not. I think that part is harder. So let me see. Messaging. I think I'm missing an annotation here, friends. Messaging gateway, Spring integration. Okay, so service interface, request channel reply, setting the default reply channel. Place gateway. That's what it is. Request channel. So gateway, request channel. So messaging gateway is this, but I can put this down here. Request channel, reply channel. Okay, that should be better. Let's see if that gives us something. No, not exactly. So void headers. Mapping methods. Payload is this. Okay, I want the. Is it always void? Can I get a response back? Oh yeah, you can request headers string. Okay, so what's the issue here? I suppose it's possible that we're just consistently getting it's not matching any of the tests. Let's see here. So, hello world. What is happening? So, greetings requests, transform it to uppercase, send it out into greetings results. Do I have it misspelled? Flow. Transform. Filtered if it contains hola. Hola. Let's just do 100. Messaging gateway. Greetings client. Greet text. So the response. There you go. Oh, that's bizarre. Why is it only doing 1? That's so weird. I don't know what that is about. Well, I'll have to look into it. But either way, maybe the response values, that doesn't work, but this definitely does, right? Like if you're doing a request, we're going to kick off the pipeline, use the greetings requests. I can't print out void, of course. Here we go. Okay, so I'm going to explicitly just call the pipeline. And then this is still going to send data on an output channel. And, oh, you know what I think it is? I think it's pullable channel. Publish subscribe. What is the direct channel? It's direct channel spec. So direct channel. Can I get that? Does that work if I use this? Greetings results? Let's try that. So wait, string. Okay. Reply channel equals greetings reply responses. That's reply. Okay. Good. There's something I'm missing here, friends. Something very interesting about, I think it has to do with threading. I don't know. We'll figure it out. Let me see. Getting the text, greeting it. Greetings replies. Do I need like a special like kind of channel? Queue? No. Direct is fine, but how do I get something that's publish subscribe dot get? What is this? This is a publish subscribe channel. Okay. It's like it's not knowing. Well, okay, whatever. So let's just say it goes into this channel, and I want to get the data. That's another good question. Another thing we should look at before we finish this, which is I want to get the data. It's being sent into the channel. How do I do that? You can actually manually connect to the channel and create and register a listener. So I can say this greetings. Let's see. That's this bean over here. It's called greetings replies. I'll inject that. It's called a message channel. Direct. Okay, here we go. Inject that into here. Okay, add that to the constructor. And we'll say up here, this dot replies dot. We want to be able to pull that, right? So it's got to be a special kind of channel. So this is a direct channel, is it? Okay. So down here, this dot replies dot subscribe new message handler, and I can just print out the results. New message dot get payload. So here I'm manually subscribing to messages on that channel. There you go. Okay, so you're able to connect to these channels. You're able to treat them as the input sources and the output sources for pipelines. You can do all sorts of things. Channels are how you think about messaging systems. Messages go in, messages come out. We have abstractions that I haven't used in a while, so I forgot how to get replies out of this. I'll figure that out, and we'll talk about it later. But basically, channels everything. If you are not sure about how to start or stop a pipeline, think about a channel. And there are some discussions around what kind of channels to use. You might have seen my video that I did a month ago on showing how to use Postgres as a message queue. And the heart of that implementation is that we're using a custom message channel that is backed by Postgres, right? Message channels give you a way to think about messaging, message systems, okay? Now, we're gonna do a quick inbound and outbound adapter example. So instead of, we could keep the channels, right? And actually, maybe we will. Let's just do that. We'll keep the channels, but we're gonna source some data from a file system, right? Okay, so we'll say return integration flow dot from files dot inbound. Oh, I need to add the build, the dependency to the build. So org Spring Framework integration, Spring integration file. Okay, gonna add that again to the build. Command Shift I. Go here. I'm gonna, not that one. The one files dot. Nope, wrong one. Org Spring Framework Spring integration file. Yeah, that should be here, right? Var inbound file adapter equals files. Org Spring Framework integration, Spring integration file. Is it not in the class path? Org Spring Framework integration, Spring integration file. There it is, 6.0. So where's the beef file? Okay, that's the issue up here. Go to our build file. Use test. Oh, I used test implementation. Oh, thank you. Oh yeah, staring me right in the face. Right in the face. There we go. Command Shift I. Thank you. Thank you. Thank you. I was like so confused, sitting here just lost in my own code. Inbound adapter. So okay, we're using an adapter. There are like countless adapters, right? So if you want to use RabbitMQ, use AMQP. If you want to do files, you do this. If you want to use FTP, you do that, right? You have to bring in the module, just like I did. Go to build.gradle or your Maven. Add the implementation, not test implementation, for the thing you want to do. So Spring Integration Black, right? Spring Integration FTP, Spring Integration Kafka, Spring Integration, there's one for JDBC. It's probably called JDBC, but I forget. Spring Integration Email, Spring Integration MQTT, Spring Integration whatever, right? There's been a number of them. And then when you add that DSL, you can then use the factory methods here. And I'm going to build a inbound adapter that's going to monitor a directory. So it'll be a new file. And I always do this trick. You probably see me do this a lot, but I want to resolve properties in this string for the environment variable. So desktop in, okay. And I'll use java.io file, a directory. And then I'm going to tell it to auto create the directory for me, and I'll say return integration flow dot from files, and I'll send it out onto this channel. So inbound greetings requests, right? And dot get. Okay, so there's this basic flow. Now, what about the data that gets written out? Well, same thing. I'm going to write another flow here to take the data that gets sent in from the replies, right? So at the end of the pipeline, we're then going to write out data to the file system, the new file. So outbound file system flow, okay, return integration flow dot from, and that's going to be greetings replies. And we're going to say adapter, right? We're going to use the handle. So here we're going to use file outbound adapter, and same basic trick, right? So directory out, and we'll say directory auto create directories true dot get. Okay, so we've got now two different things that will send data into the system and write data out to the file system. So from the file system into Spring Integration, and from Spring Integration out to the file system. Let's run this and see what we get. Okay, what is this from? Oh, do I have a runner? I still have this runner. Right. Okay, so ignore that. Let's just ignore that for now. Okay, so I've got nothing happening until somebody writes a file to that directory. Nothing will get sent through this text. Okay, so now we go to the input directory, nothing. Echo hello to a file called random, right? Random. Okay. What about hola? Okay, so now desktop out. Oh, because it ran before, right? So here we go, out. Restart. So here we go. And over here, let's go over here. We'll do watch -n lsla. Okay. And then we'll do a cd desktop in. And what do we have here? So wait a minute. So the greetings replies is coming from here. This should be going to, oh, am I in the right directory? Oh, yeah, I am. Okay, so what's the flow? We've got an uppercase. If it contains hola, it comes in from this channel. So we get the data. Let's just write it out quickly. Handle, new generic handler, string, and we're just going to return payload. But I want to log it out first. Observing payload. Okay, so there's this. And by the way, there's actually an operator you can use that makes that, even what I'm doing right there, called wiretap. So if you want to like log the result of a flow to debug it or to handle something, you can wiretap the message by saying .wiretap, and you can pass in a wiretap channel, an integration flow. You can send, without stopping the current flow, you can send the data off to another flow to like observe or log or send messages or metrics, whatever, all that kind of stuff. Okay, so now let's do nothing. What about hola? What did I do wrong? Oh, see? I'll bet you I know what it is. It's this polar. You gotta like tell it when to pull. Yes, that's what I think it would be. Okay. So, greetings requests. Are we seeing anything here? Source greetings request. Are we seeing that happen at all? So, file inbound adapter flow from files to greetings requests, right? Channel greetings requests. It should arrive here. Do we get to this point? Console. Okay, well, how come we're not seeing it? Is it the right directory? D, desktop in. What the? This is the file. I'm so confused. Why is it upset with us? So from this to the greetings request, let's just call this requests to be simple. Let's get rid of all the stuff that is distracting from this. Okay. Where's the replies? Inbound, outbound. So it's obviously, okay, this is so, like, time to reset on the basics here. Okay. Okay. Now what? Your move code. So we see in and out. Good. So what about in? cd in, echo, hola, to a file called random. You should at least see a inbound event when I do that, and I'm not even seeing that. So the requests. Did I miss something? Huh. Completely confused. PM. Okay. Fixed rate. This is supposed to be milliseconds, right? Payload. Okay. This is just before anything is doing the filtering. We should be able to see this, right? I mean, new payload. Yeah, okay, it saw the file. Great. So now what? It's sending the file into requests. Oh, friends. Sometimes it's so obvious it hurts. I should turn on debug logging, and I'll bet you I know what it would see. It would see that I'm getting data from this inbound adapter. What is the type of that inbound adapter? It's file. It's not string. Something needs to transform that into a string, okay? Which gets us to a great point. We need a transform. So a new file to string transformer. How much want to bet this one does a better job? Okay, good. So now, see, this is not going to work. There you go. Observing, hola, yes, finally. Okay, so the program started up. We don't have anything blocking the thread to keep it open because it's not a web server. So in order to make this work a little bit more event-driven, we're going to block the thread here. We'll say thread.join to keep the JVM running, right? Thread.join. Close the section. Okay, so process is running, observing hola, right? Etc. Each time you see that, it's observing the results. So we can get rid of that. So we got the data from the inbound adapter, which is here. It's taking the data every 1 second. And by the way, I truly think this will default to 1 second, so we can remove that. Let's see here. Maybe we did need a puller. I don't know. Let me see. Leave that back in. Good. Fine. Leave the puller there. So, okay, it's getting the data from there every 1 second. It's turning it into a string, sending it on the request channel. The request channel then flows to this flow over here, right? Inbound, and then goes to the flow from the request channel. We take the string, test to see if it's got the string hola. If it does, we uppercase it, and then we send it out on the replies channel where it goes here, right? So outbound flow and inbound flow, right? And so then if we've done our job correctly, we don't have this directory anymore, but if we did, there's all these files. So get rid of all that. RMRF all this. So now what? So we do echo hola. There it is. Oh, so painful. Okay, good. I was so confused. Now 30883 is the name of the file. Notice that it preserved that, and the way it's preserving that file name is through headers. Headers are out-of-band information that communicate things about the payload. They're not the payload itself. They're metadata about the payload. And behind the scenes, remember, everything is a message channel with a message, and messages have payloads and they have headers. And you haven't really seen me using those headers, but they get propagated each time, right? So, for example, if I wanted to do things manually, I could do this. I could say handle new message handler, right? Here's the low-level interface. And I get a pointer to the message itself. My job is to, do something with it, right? So maybe I want to use the generic handler. New generic handler. String. I'm going to take the incoming string payload. I've got the message headers there, but you can see the headers there are kind of interesting. It's just a key value map. Right? Good. Restart. You can see when I get the inbound message, Spring Negation populates the message with headers. File original file name equals blah, blah, blah. File name equals this. This gets perpetuated. So if I took this code and then added it to the very end of the flow, right before it gets written out to the file system, I can say from replies, handle, print out the stuff. So here we are, at the end of the line. Okay, so there's this, and here's the flow, start of the line. Let's see what headers get propagated automatically. Okay, end of the line, file original name, file name, blah, blah, blah. So behind the scenes, these components, each component hands off to the next and it creates a new message, but it copies the old headers from the old message and puts it into the new one. And you can change things. Like, let's say here at the end of the line, right? If I go down here to the end of the line, let's say I want to change the headers, right? Well, I could do that. I could actually enrich headers by adding my own custom headers there, right? Or you can actually just do it low level. You can do like a transformer, right? And you could create a generic transformer. Is there one where I can use the message itself? I want the message. Generic transformer. Service activator. Handle. Maybe handle is the best one? I don't even know. What's the best way to like add message headers? But anyway, that's a thing you could do. You could totally add new headers along the way. If nothing else, you can use that enrich headers. But it's also possible to get a hold of the message and then create the new message in the way that you want as well. Okay, friends, that was just a very, very, very basic. We haven't even done anything useful. We've seen the arrangement of flows and channels and messages in the system. We've seen how Spring Integration makes it easy to write functional, sort of well-defined components that string together to form and solve bigger problems. We've seen that there are lots of ways to reuse Spring Integration flow. So you can launch an integration flow manually using the integration flow context. You can use messaging gateways. You can use just channels directly as the interface. But basically, the intent here is that you have a whole bunch of business logic hidden behind a message channel, and Spring Integration will automatically sort of make that available to the rest of your application. You can have this living off of a Spring Boot application. So imagine something more interesting. Imagine you've got a web application and you're doing work, you've got an HTTP request that comes in, you do something in Spring MVC, you inject a message channel, you put it, or a messaging gateway, like the interface that we saw earlier, you call the method on that and it calls Kafka, right? So instead of using a file system, you might have a web endpoint you might have an integration flow that calls Apache Kafka or Apache Pulsar or a JDBC adapter or something like that, right? And the web code doesn't need to know that this messaging client is actually talking to a very complex set of pipelines, right? A whole subsystem. So, friends, this was fun. We'll do this again. Maybe this weekend. I'm not sure. I'm going to try and do as many streams as I can in the next week or so, because next week, at the end of next week, it's my daughter's spring break. She's a senior in high school, and this is her last year in high school, and then she's going off to college in the fall. And so we're going to go down to look at some colleges over her spring break. So I'll try and stream when I'm on spring break with her, but it might be hard. We might go to Disneyland. Who knows? Life is hard. So, friends, thank you. Have a great day, great weekend, and see you next time.